which is going to be Predictors of Happiness by Luke Johnson and Stephanie Wiese.
Thank you, Charlie. Like she said, I am Stephanie Wiesen.
And I'm Luke Johnson.
And representing Predictors of Happiness today. So, I'll begin with the age-old question. What is happiness? Ben Franklin said it's wine, or in his more well-known version of the quote, beer. Pharrell Williams sings that it's a room without a roof. And the Founding Fathers didn't really specify, but they promised that we'd all have the right to go after it. Research has said many different things. It's money, good genes, appreciation. No one can really agree, but either way, explaining it seems just as elusive as predicting it, which, like many before us, we set out to do in this study. Both psychologists and economists have been increasingly studying happiness since the 1980s. Despite the increase, there's not been a whole lot of consensus on how to be happy, both in the academic literature and in the popular culture. One of the reasons for the latter being that the way they study it is different. Economists use objective, hard data, things like age, gender, race, marital status, income, whereas psychologists use subjective data, or in this case, life domains, which is reported attitudes and perceptions on different dimensions of one's life. Even with objective being hard data, there's been a lot of support for subjective domains doing a good job, if not a better job, of statistically explaining and predicting happiness, which is good since we use them for our study.
So in this analysis, we extended prior research by looking at different predictors of happiness. Using the national research data, we studied the domains of family income, job satisfaction, family satisfaction, and health in order to predict one's happiness. So the first predictor I'll talk about is income. So previous research has showed that subjective well-being differs very little even when material circumstances are very different. So for example, a person in Tanzania would have the same subjective well-being as a person in Switzerland. In contradiction to that, there's a study conducted in 1999 using U.S. citizens that found a correlation of 0.12 of wealth to reported happiness. So this poses the question, does money buy happiness? Well, more money doesn't necessarily buy happiness, but not having enough money to satisfy your basic human needs does contribute to emotional pain. So the general consensus is that beyond a certain threshold, more money doesn't affect happiness. So if you're a U.S. citizen, the threshold is $75,000, and this varies from state to state. But any earnings above that will not necessarily increase your happiness. So these studies allowed us to predict that family income will have a significant positive relationship to happiness.
Which brings us to the next two predictors. The past research supports that the magnitude of happiness varies from high to low, with family life, financial situation, job, and health in that order. When the effect has been considered singularly, family satisfaction is the most powerful predictor. There are two theories that support these, or the impact of these predictors. The first is the compensation theory, which states that a successful family life can compensate for an unsatisfying job. So for anyone who's had a bad job but been able to come home to a healthy, happy family and be happy regardless, this theory will make sense to them. A competing theory to this is the spillover theory. So if you hate your job, basically it will say that this frustration and unhappiness will spill over into all over the domains in your life. The literature supports both of these situationally, but both theories indicate the relevance of family, who we spend the most time with, quality time, and job, where we spend the most time at, as relevant predictors of happiness. Which leads us to predict that job satisfaction will have a significant positive relationship to happiness, and family satisfaction will have a significant positive relationship to happiness.
All right, the last predictor we'll talk about is health. So a study conducted in 1997 used 5,000 Swedish adults, and they found health to be a significant positive predictor of happiness. Another study looked at the set point theory, and what this theory basically says is that humans are resilient and usually adapt to their set state of happiness, even after a traumatic health incident occurs. So health doesn't necessarily affect one's happiness, at least not in the long term. So for example, if you're in a motorcycle accident and you became a paraplegic, your happiness levels would drop, but only momentarily, and you would soon get back to your set point of happiness. So one of the most comprehensive studies involving set point theory compared disabled people to non-disabled people. And what the results showed is that people with disabilities had lower levels of happiness than those with no disabilities. So this is kind of contradictory to the set point theory and allowed us to predict that health will have a significant positive relationship with happiness.
Which brings us to the study. So the survey we used is a general social survey. It's a continuing study of American public opinion and values, which began in 1972. It contains the standard core of demographic, behavioral, and attitudinal questions, plus topics of special interest, which include civil liberties, crime and violence, intergroup tolerance, morality, national spending priorities, stress, and psychological well-being, which is what we used. Altogether, it's rated as the single best source for sociological and attitudinal trend data covering the United States. We used the 2012 MERGE data to investigate the predictability of the 4 factors that we've discussed, or independent variables, of health, job satisfaction, family satisfaction, and income, with the dependent variable being the respondent's reported level of satisfaction. We used multiple regression and had 251 participants. The type of data we used will self-report scale variables, with the exception of income being nominal. We used forced data entry because we were supporting previous research findings.
So what were the results? 3 out of the 4 variables were significant in predicting happiness. So family income was not a significant predictor of happiness, which is not supporting of our first hypothesis. Family satisfaction was the highest, which did support our second hypothesis and also previous research, followed closely by job satisfaction, also supporting our third hypothesis. The least significant predictor was health, and even though it was significant, so it supported our fourth hypothesis. And the combination of these 3 significant predictors produced an R-square of 0.402, which states that the combination of these 3 variables accounts for at least 40% of our happiness.
So there are a few things that our study highlighted and found. The first, that is contrary to popular belief, it's not about the money, or in this case, the family's money. So generally speaking, the higher you're paid, the less free time you have to spend with loved ones, which this could be a possible mediator and something to investigate in the future. In addition, our findings support previous existing literature. As you know, we investigated attitudes and perceptions. These were contributed to 40% of happiness. And as you can see, this supports and fits right in line with previous research suggesting that this model fits great, and also that it continues to support this trend.
So to recap, family satisfaction, job satisfaction, and health were all significant predictors of happiness, with family satisfaction being the highest predictability and family income having no significant prediction whatsoever. And any questions?
2, can you tell me a little bit about your demographics? The age of your participants, a range, and then the income of your participants.
Well, we use, what survey did we use?
We use the General Social Survey, so there's probably tens of thousands of people. We narrowed them down off of the four predictors, which really kind of put them together. I know that of the 251 participants, the median age was around like 40. As far as gender, we didn't really get into the statistics like that far because we're not that advanced, frankly.
The income of the participants? If you're making the statement that income didn't have any effect, and you have a population of people that have fairly high income, why would you expect anything different when you just made that statement, 75,000, that they have a level of 75,000 and it doesn't make any difference? That's a comfort level.
True.
So you probably want to take a look at what their income was, and then the age. I think age, to me, would make a difference. If you have a population that's younger.
That's true. With age, there's a positive and relationship. So it starts out younger, higher, and then mid-aged, it's down, and then when you get older, it goes back up again. So I suppose that would be kind of relative, right? That's surprising, I suppose. But yeah, we should have printed that out.
Yeah, for sure.
Can you go back to your little pie graph a couple slides back? So you're saying that you're finding support the pie graph, the 40% of actions and thoughts.
Yes.
Okay, so this missing 60% in this pie graph is 50% of that is genetic.
It's actually the set point theory, which is what Luke talked about. It's not only just genetics, but it's if you're familiar with positive psychology research, Seligman found that essentially you're born with a set point where you're either 3 drinks ahead or 3 drinks behind, but you stay there in that range. So yeah, right, the positives, like the pessimist and the optimist, like me and Luke were like, what are we? But yeah, I mean, that's actually how we got to this research, is we did this study or researched this in our undergrad, and we couldn't believe that, really.
Yeah, we were pretty upset that genetics accounted for that much because we'd like to think we have control of our lives.
Right, I'm not that familiar with psychology, but I like this 3 drinks ahead.
3 drinks behind. That's actually, that's a quote by Seligman. Yes. Any other questions?
Thanks for having us.
Yes, thank you very much.
Charles is going to do a presentation on maternal psychological stress and cyclophosphamide teratogenesis in CD1 mice. Okay, turn it over to you.
Maternal stress is a topic that many expecting mothers, it creates great worry for them. And maternal stress is reflected in the market. So there's a huge market for maternal stress products such as magazines, DVDs, and even specialized workout programs. Our goal in this experiment was to examine whether the maternal stress was going to affect the incidence of cyclophosphamide teratogenesis. We first became interested in cyclophosphamide teratogenesis in conjunction with stress after going to an academic meeting. And we became aware of it, and so that this study was right up our alley because I had previously been working on cyclophosphamide in conjunction with antioxidants in my undergraduate work. So this led us to the question: how will stress affect cyclophosphamide teratogenesis in our model? So can we get these effects in our lab? So we hypothesized, just as you probably suspect, that more stress equals more birth defects. But as the title hints, that's not exactly what we found. So we have to talk about a few things before we can go ahead and talk about the results. And here we're going to first look at psychological stress. So we created psychological stress by using restraint. And restraint stress is just confining an animal for a set period of time. And this causes them to be uncomfortable, but it doesn't harm them. So we have 4 treatment groups: control, stress, stress plus cyclophosphamide, and cyclophosphamide only. So this, we're going to give you a general idea, a rundown of the experimental structure. So you may be wondering, why do we need the cyclophosphamide? You're studying maternal stress. Why do you need cyclophosphamide? And the answer is, it has to do with the way birth defects work. Birth defects may occur 1 in every 1,000, 1 in every 10,000 times or events. So it's impractical to sit around in the lab and wait and process that many mice. You're not going to be able to do it. It costs too much. So we need to artificially raise the floor, or the instance of birth defects. And that's what cyclophosphamide does. Cyclophosphamide is an anti-cancer agent, and it's a well-known drug that we use in studies to create these birth defects so that we can observe them. Okay? So here are 4 treatments: control, stress, stress and cyclophosphamide, cyclophosphamide only. Here are examples of birth defects. These are all pictures taken from our lab, and these are gathered through microscope observations. And here's the resulting graph. So I want to remind you, our hypothesis was that more stress, more birth defects. But that's not what we found. Okay? And so what we did find was actually the inverse. So these blue bars here, remember that is the stress plus drug. And these pink bars here is drug and is just drug alone. So we would expect that the stress would make the drug's birth defect rate higher. Okay? But that is not at all what we saw. So actually in digit, bloating, tail, limb, and limb defects, we saw that somehow the stress seemed to be reducing the incidence of birth defects. So what a surprise. How unexpected. We do not have a mechanism for this yet, and so we don't have a mechanism yet. That's going to require further study. Right now, I am working on processing skeletal data. So you'll notice that you can't see the bones in these ones. All right, so we're looking for then rib malformations, things like cleft palate, spinal column malformations here on this mouse. So I will be processing skeletal data right now. So that's where the current step we are on. And so really, as always, we have, this really just raises more questions than answers. And so we will take, and it's just going to take more and more study. And so it raises more questions than answers. But I think that this result is surprising, unexpected, very neat, and just it raises your curiosity. So what's going on? So we'll continue to process data, and maybe next year.
Okay. Questions? Gerald?
How many animals are you looking at? Your results would be the same if in fact stress plus cyclophosphamide killed off more embryos that went through complete
So
development.
here's where we were running into the one slide problem. I have a bunch of other data that supports that that's not indeed what's happening. So we're not seeing more resorbed or dead mice in these
In the
cyclophosphamide group than the other ones.
The stress plus phosphamide.
Right, yeah, we're not seeing more. So you would say, okay, well maybe these mice just died, right? They died in the mother and I never saw them. But that's not the case because I examined them. I examined all of them. So I do keep track of how many are resorbed, how many die. So there is, that's not what's happening.
Well, one thing stress does, the hormones raise, the stress hormones. Have you considered using hormone injections instead of stress to see if that is tied to the cyclophosphamide
I haven't.
phenomenon?
No, I haven't. I have considered trying to test the hormone levels in the animals after their stress treatment. So I have considered that. Yes.
It's really hard to tell in the graph there, but if you just looked at just the control group and the stress alone, those two, any significant differences between?
No, no, there weren't. So I took off the error bars here because it's getting really crowded up here.
Right.
So there are error bars, just not on this graph. And so no, because there wasn't any difference in between the two. other than weight. The weight of the mother was different in the restrained ones, and the weight of the fetuses was slightly larger. But and we were really checking to see if stress exacerbated or made worse the effects of our drug that causes the birth defect. So it makes sense that you're not seeing a huge instance because there's no drug here to cause those defects.
Yeah, I just kind of, I mean, I just wanted to stress alone, if that's the worry of mothers.
Well, yes. So stress alone is the worry of mothers, but they're also doing other. You're addressing then a part of the population that are stressed mothers that are also maybe using a drug in conjunction with them. But as for stress alone, yeah, it's kind of a hard hit directly off.
Thank you.
Any other questions? Thank you. In the program, it's a friend or foe. Will vitamin C help the anti-melanoma drug to combat against human malignant melanoma?
Hello everyone, my name is Yao Yan, and today I'm going to talk about the effect of vitamin C on the cytotoxicity of phenolphthalein against melanoma. Okay, first, what is melanoma? Melanoma is called skin cancer that produce pigments, and about 50% of melanomas are caused by steroid mutations. And traditionally, we will use chemotherapy and immunotherapy and radiation therapy to treat melanomas. But current therapeutic strategy focus on targeting specific genes on signaling pathways. And in this project, we apply two drugs to treat the melanoma cells. First one is phenolphthalein, which is also called PLS4032. And phenolphthalein is one of drug inhibitor, and it was approved by FDA to be used clinically and has achieved several success. And the second drug is vitamin C, which is also the class antioxidant, and it can kill some types of the cancer cells as a plant oxidant. In this project, we have to figure out several questions. First one is vitamin C cytotoxic to malignant melanoma cells? Second one is, does vitamin C inhibit or enhance the invasionase of melanoma cells? And thirdly, does vitamin C affect cell cycle progression and induce apoptosis? And finally, does vitamin C exist synergistic effects with PLS4032? And we use SKM-EL28 and A2058 to melanoma cell lines to do our experiment. And first one, we use MTT assay to test the cell mobility. And second, we use a transfer immunoassay to test the invasionase of melanoma cells. And we do the flow cytometry to test the cell cycle progression of melanoma cells. And then we use apoptosis assay to test if the drug can induce melanoma cells apoptosis. And finally, we use a Western blot to test the expression level of several specific proteins. And this is results. And first one is results of MTT, and this is effect of vitamin C or vitamin C together with PLS4032 on cell mobility. And from the figure we can show that the high concentration of the vitamin C can significantly decrease the cell mobility. And the PLS4032 can also significantly decrease the cell mobility. Okay, however, let's focus on this group. So we can see that the high concentration of the vitamin C exists strongly synergistic effect with PLS4032 on reducing cell mobility of melanoma cells. And then this is the effect of vitamin C on cell invasionase. We can see that the combination, the high concentration of vitamin C and the combination of the vitamin C and the PLS 4032, they all can significantly decrease the investment needs of melanoma cells. So this one should be works better than all other groups. And then this is the effect of vitamin C on cell cycle and progression. Okay, for, the red area is the G0, G1 phase, and the brown area is the G2L phase, and the brownish area is the S phase. Okay, compare with the brown area part, we can see that compared with control group, the vitamin C group can actually promote cell cycle progression. But the PLS 4032, it can arrest the cell cycle at G0, G1 phase. As a combination of the vitamin C and the PLS 4032, they also can arrest cell cycle at G0, G1 phase. But from this group, we can see that the vitamin C can actually promote cell cycle progress. And this is the effect of apoptosis, cell apoptosis. And this is control group and so vitamin C alone group. And we can see that the vitamin C can induce cell apoptosis. And this is combination group of both these two drugs. And we can see that vitamin C alone and both the combination of vitamin C and PLX 4032, they all can induce cell apoptosis. And the next figure will show, this next graph will show us the apoptotic level of each group. This is the control group. And we can see that the combination of these two drugs should be works better than vitamin C alone. Okay, that's the results of the Western blot. The effect of vitamin C and PLS 4032 on the activation of signaling pathways. We test the expression level of several different proteins. First one is phospholipid drug. You can see that the high concentration of the vitamin C can significantly decrease the expression level of phospholipid drug. And we also do the expression level of non-phospholipid drug, but I didn't show it in the picture. It should be expressed at the same level, but this is no difference in the expression level of non-phospholipid drug. But the high concentration of the vitamin C can decrease the expression level of phospholipid drug. And the second one is the expression level of phospholipid AKT, and we can see that there's no significant difference between the expression level in these groups, which means that the vitamin C can control the cell proliferation, rely on the raw pathway, not rather than AKT pathways. And we also do the tests of expression level of phospholipid ERK and non-phospholipid ERK. And here we can see that the expression level of non-phospholipid ERK should be same, almost the same in all these groups. But the high concentration of the vitamin C can significantly decrease the expression level of phospholipid ERK, which means that the vitamin C can control the cell proliferation by control the expression of phospholipid ERK. And we also do the in vivo test. We inject the vitamin C into the mice and then test the size of the tumor, and we find that the red line is the control group, and the brown line is the high concentration of vitamin C, and the brownish line is the low concentration of the vitamin C. And the high concentration of the vitamin C can decrease the melanoma growth in mice. However, the low concentration of the vitamin C can increase the melanoma growth in mice. It's pretty funny, I think. So the conclusion, first, vitamin C is cytotoxic to melanoma cells. Secondly, vitamin C has synergistic effect with PRX4032 on inhibiting cell mobility and investments. And vitamin C supports the activation of the ROCK signaling pathway. And the vitamin C at lower concentration can increase melanoma growth in mice, while the high concentration of the vitamin C can decrease melanoma growth in mice. Finally, I'd like to thank my advisor, Dr. Yang, and my lab members for assisting this study.
Can you explain why you're actually interested in the AKT or BRAF, MAPK pathway?
Because a lot of cancer, a lot of research shows that a lot of cancers are related to the BRAF mutation or AKT mutation. That means the BRAF and AKT plays a very key role in the cell proliferation or cell cycle process. And which means if one of this protein is mutated, then it may be the key function of this protein will lose and will cause a series of mutations or the downstream genes of this K protein will cannot work or overexpress. That may be cause overexpression of the tumor cells or the deactivation of some important genes that can inhibit the cell proliferation.
Can you go back to the Western blot slides, please? Okay, so that's fine. So you always talk about expression level. I don't think it's expression level, right? It's activation level, right? So gene expression expressed at ERK112 is already there. Just whether or not you phosphorylate or not, right? So it's not expression level.
Or phosphorylation level of
Yeah, the activation level probably is more accurate.
Mice, I believe, make their own vitamin C. Humans do not. We lack one enzyme in 11 steps to make vitamin C. What kind of doses would be an equivalent human dose in terms of what you're talking about, in terms of the synergy between vitamin C and this anti-cancer drug?
I think it should be 1 milligram per kilogram. It depends on the
1 milligram, okay.
yes, depends on.
So do you think that the fact that mice make vitamin C somehow influences your results? Because what you're doing is you're giving them a higher dose, those cells, and you don't know what the normal dose is. So the fact that you're showing an effect is nice, but I think when you're looking at the human picture, it adds a question of variability. But maybe human cells would be.
I was not aware that mice cells actually produce vitamin C.
I think the only mammal that does not, besides us, is the Dalmatian dog.
Yeah, that's a very good point. We should actually look into that. I was not aware about that difference. So that means I can take a high dose vitamin C, but not low dose, right? High dose probably kill cancer. Low dose probably promote the growth.
I don't think so because every day maybe we should drink the orange juice and we eat some oranges and in that the drink also the fruit it don't contain very high concentration of the vitamin C. But does it mean that take the drink or eat oranges can get cancer or promote?
But I can use IV to treat the cancer with vitamin C. Yes, we do that. Yeah, we do that. KMC do that.
Okay.
Yeah, you IV because the digestive does not achieve very high concentration of vitamin C. If you orally take it, it does not achieve that high. You use 2 millimole, right? This is very high concentration.
Yeah.
So, but IV can achieve that concentration easily. It can even achieve 10 millimole in the serum.
Thank you.
It's my pleasure to introduce to you Lon Piva, and she's going to talk about the impact of fuel, or impact of, yours is different than what's on. The impact of fire season with litter load addition effects on the control of Cercia lespedeza.
Awesome.
Thank you.
You so much. All right, so each year, invasive plants cost the United States over $34 million in treatment and in crop loss. One such invasive plant is Cercia lespedeza. You can see it here. This plant is very, very invasive because it has rapid succession, has prolific seed production, and it can also form really dense stands, which outcrowd native species. It was originally brought over from Eastern Asia in the late 1800s for forage control, or forage production and erosion control. But unfortunately, when they brought it over, they didn't really think about the implications of it being an invasive species. And so today, it is in over 62,000 acres in Kansas alone at the tallgrass prairies. And since there's only 4% of the national tallgrass prairies left in the United States, it makes it really imperative that we try to control Cercia lespedeza. So currently, there are 4 methods of control. The first is spraying with herbicide. This is very costly and can also cause detriment to native species. And then you also have to do repeat application. So it's not just a one and done, you also have to do it every single year or even multiple times. The next would be mowing, so actually mechanically removing Cercia lespedeza. Again, this has to require repeat application and also can be detrimental to some of the native plants. And then we have fire. So fire can control, has been shown to increase Cercia germination in the spring. So although a lot of people think that fire might control Cercia lespedeza, it's been shown to actually enhance it. And then grazing and fire combined in a patch burn effect. So you have 3 sections of pasture, one is burnt, and the cattle are allowed to graze on it. Then the next year you burn the next section and the cattle are allowed to graze on that. So you can see here, this is the range of Cercia lespedeza. So it was brought over and then it spread all the way to the Midwest. In about the 1930s, it reached Kansas. Here it's listed as a noxious weed. But in our surrounding states, it's actually listed as an invasive species. The goal of my project was to target Cercia at its vulnerable life stages. So these are 3 stages. So germination, when the seedling actually comes up in the spring, seedling development under a year, and then seed production. So to target germination, this would be burning in the spring, though, like I said, there have been studies shown that burning in the spring can actually increase germination. The seedling development under a year, this can also be targeted with the grazing. So the cattle and goat will graze on Cercia lespedeza if it's under a year of age. Once it becomes over a year of age, it's too high in toxins and the cattle won't eat it. And then the third, seed production, we target this with burning in the fall, trying to catch the seeds while they're on the plant. In order to do this, you actually have to reach a fire temperature of 225 degrees Celsius, and that will kill most of the seeds. If the fire reaches 250 degrees Celsius, there are no seeds left. They're not viable at all. So my experimental design incorporated 2 different things. So fire season, so one was unburned control, one was fall, and one was spring. Then we coupled that with herbicide application, litter addition to try to get the fire temperature hot enough, the mowing, and then just a burn only. So within these fire seasons, we did all of these treatments as well. My hypothesis was that the fall fire would, with the litter load addition, so the increased fire temperature, would have the largest decrease in Cercia, mostly due because we'd be catching all the seeds before they would come back and be incorporated into the soil the next year. An objective was to create a management tool for land owners around this area to try to control Cercia lespedeza, but also maintain the integrity of the tallgrass prairie. So we don't want to damage native plants, but we do want to decrease Cercia. This is my site location. It's at the Mersey National Wildlife Refuge in Pleasanton, Kansas. It's about 2 hours from here. It's very even and dense dispersed Sericea lespedeza. And our study plots are the ones that were indicated with a 1 after any of the letters. So we had the fall burn, which would be the F1, and then the springs, and then the control were the unburned areas. So we had these 50 by 50 meter plots, and then we broke them down into 25 quarters, 25 meter quarters, and assigned mow, litter, herbicide, or burn only. So you can see again, 4 treatments. We also had between each of them, a 5 meter burn break. That way the fire didn't hop to one of the other plots and throw off the experiment. And here you can see an aerial view. This is actually a 50 meter plot right here with the 4 quarters. And you can kind of see the difference in those 4 quarters. Here is where we spread the hay to try to get the fire temperatures hot enough. It's actually a half of a round bale of hay, so you can imagine these huge round bales. We had to spread it by hand. So we had a farmer volunteer his time, and he unrolled the hay bale for us, but then we spread it out by hand from there. Here is a mowing plot, so you can see Sericea is really, really dense. This is an herbicide, you see no Sericea at all, and then this is the burn only. And then our handy little fire guys are lighting the fire around it. This is from Google Images, so you can just see how big the site area is. The imagery hasn't been completely updated, so there is another row of plots. But we didn't do too bad, they're pretty straight. Also, at the site, we collected climatic data to see if this would make a difference, and it actually did. So if you see right in the growing season, so this would have been about April to August, there was 76.3 centimeters of rain versus the 44.4 in 2014. So pre-burn to post-burn, we had a lot more rain after the burn. So you can see a little bit better, that 72% increase in rain from year to year. To collect my data, what we did is in each of those 50 by 50 meter plots, so if you zoom in just to 1/4 of it, at each of the 4 corners, I set out a quadrat that was a meter by a meter. And in that quadrat, I collected stem density. So I counted how many stems of Sericea there were. And then at each of these 4 corners, I also collected the standing biomass. So I did 1/4 of a meter squared, so just 1/4 of this. And I clipped off all the grass and all the forbs in that area, collected it, put it in a bag, brought it back to campus. Once I got back to campus, I dried it. I sorted it into the 3, so grass, forb, and Sericea. Sorted it into those 3 different groups. And then I weighed it to see how much productivity was there. So that brings us to my results. What did we actually find with our control and our treatments? So if we're looking first at the stem densities, so how many did I count? Really the only big difference here is between the different fire seasons. So we pull it up. If you look at just fall, we burned in the fall. The difference here is we have a significant difference. The herb and the herbicide is significantly different from the litter and the fire only, which is, this is to be expected. Everybody knows herbicide works really well. We're trying to avoid that. We don't want to have the chemicals or the cost of using herbicide. What it did is just went to show herbicide is really effective versus adding the litter and just burning. If you look at the spring, kind of see that same trend with the herbicide versus, with the herbicide versus the fire only, but not between the mow and the litter. And then in the unburned area, so this is the area that we didn't touch with fire at all, but we still applied herbicide and the mowing and the fire. You see that the herbicide still had a significant difference from mowing and fire only. So really, herbicide works great. That's the take-home message from this one. If you look at the percent difference in stem density, so this kind of takes into account how many stems were there from the get-go versus how many came back, that percent difference. We didn't see anything but one significant difference, and that was in the herbicide plot. We had a larger increase in the percent difference versus the mow, litter, and fire only, and just in the fall. So we had more stems come back in that fall herbicide plot. The total standing biomass, so again, this is taking all the grass, forbs, and sericea together and weighing it, how much was in that area. We have a lot of significant differences here. So the first is within the different treatments. So we have some significant differences here with the herbicide and between the spring and the unburned. We have significant difference here. The unburned was significantly higher with total standing biomass. We see that again here, the herbicide, or the mowing between the fall and the unburned. Again, unburned was significantly higher. And then here again, with the fire only, we had higher standing biomass. If you break it down by just the fire season, we have a significant difference between the mow and the litter addition. So the litter addition actually burned hotter and caused the sericea, or the total standing biomass, to be higher. In the spring, we see that same trend. We see that same trend. The litter addition is significantly higher than the mow and the herbicide, so that hotter fire allowed the standing biomass in the spring to be higher. And then with the unburned, what we see is that the herbicide and the mowing, they have significantly lower total standing biomass. So by burning unburned with the herbicide and the mowing additions actually has a lower total standing biomass. Grass standing biomass, this is really important because this is what we're trying to preserve. We want the grass to stay and be healthy. So if we first look at the different secondary treatments, we see a significant difference between the spring and the unburned. The unburned had a higher grass standing biomass if you add in the herbicide. That was the only significant difference that we saw. Then if you look at just within each of the fire seasons, the herbicide had a significantly higher grass standing biomass. So adding herbicide plus burning in the fall made the grass come back better. Same trend in the spring. If you added herbicide with the spring burn, you had higher amounts of grass. And then if you didn't burn at all, but you added herbicide, you saw the same results. It was significantly higher than mowing and fire only. Interesting trend to point out is that anywhere where there was a high stem density of sericea, so if the density of sericea is high, the grass is actually really low. So in these three, the grass is lower where the sericea is higher. It kind of goes back to supporting the idea that sericea forms those dense stands and is outshading the grass species. When we look at forbs, we didn't see any significant differences in the forbs. So things like milkweed or any shrub, we didn't see any differences. So then that brings us to sericea, the plant that we're trying to control. How was this affected? We did see some significant differences between secondary treatments. If you look at mowing, if you add a fall fire plus mowing, you have a significant decrease in sericea. Okay. In the fall, kind of the same thing. If you add herbicide and mowing, you have a significantly lower amount of sericea. Let's see. So if you look, this is then after the burn, and this is a fall plot. The litter addition had a really even burn, which caused all the competition to be gone, all the native grass and all the native forbs, and that allowed the sericea to come back a little bit better. So really, in conclusion, prescribed burning versus no burning, you definitely want to do a prescribed burn. You see a decrease in Sericea lespedeza. Mowing, it can actually decrease the amount of standing biomass, especially if you add it with a fall burn. So this kind of brings us to the idea that maybe we should be burning in the fall versus burning in the spring, because that is what is traditionally done now. So you burn in the spring. And then really a lot of our significant differences had to do with how much water was, how much precipitation there was after the burns. So those are my acknowledgements. So if you guys have any questions, I'll take them. Yeah?
Do you think rainfall affected the burn rate and as a contributing factor?
It could be it could be a factor. So Another aspect of my project that I didn't present was actually litter, how much moisture was in the litter load before we burned. So we would collect the litter load and then measure the water content essentially. So if there was higher water content, it probably didn't burn as well versus if it was really dry, it would burn really quickly. Yeah, so it definitely affects it.
What kind of practical applications do you think this would be useful in the Midwest in this area?
It would be very practical because the sericea is really invasive here, and a lot of farmers and landowners can't control it. There's just not really anything right now that's effective. So if they do switch to a fall burn, could be something that might help, because it doesn't negatively affect any of our native species to burn in the fall. The only thing that could be a factor is erosion. That's why people burn in the spring now, is because they don't want erosion to happen after you burn in the fall.
You presented on this before, is this
Yeah,
correct? Yes, yes, so-
multiple times.
Yes.
Oh, I already defended my thesis, so.
Yeah, so this is all kind of familiar. It's kind of nice to see it kind of come to conclusion. How many, just offhand, how many hours did you put into this? Because this is very impressive. You've obviously done a lot of work.
Yeah.
You're traveling, you're building plots. Just how many hours did this project
An
entail?
unbelievable amount. I mean, so we collected data for 2 years, so once in 2014 and again in 2015, and I probably took 10 trips each of those years, so a total of 20 trips out there just for collection.
Right.
That doesn't include the days we had to go out and burn. And those days, we would be out there, those trips, I mean, 6 hours straight to 10 hours straight, just depending on how much we had to get done.
Right.
And then we had to go out for each time we burned, we had to go out and help and collect data right before we burned. We had to go out and spread the hay. And then when we got back to the lab, I had to sort and do everything in the lab. Yeah, so a lot of hours.
Well, congratulations.
Thank you. Yeah, I'm like, can I get my doctorate from this? No, I'm just-
Right, yeah, really.
Yeah, no, but these were my nice little helpers, my dogs.
Yeah,
Yeah, they're good boys.
sure.
All right.
Thank you very
guys.
much.